Okay, so this work is a joint collaboration between Politecnico di Torino, where I came from, and St. Louis University. And this collaboration is quite fruitful, and that's why we work very well. And I think we achieved something really interesting, even in NGI. So I prepared this slide for explaining what we did and why we did this, but
let's interrupt you. Maybe you could sit just in front of the
projector.
projector. Let's.
Okay, I'll stay here. Yes. Okay. So I prepared this slide, as I was saying, but your presentation made me think that there are many reasons for using our platform. And so many of you were talking about machine learning and federated learning. And some others have tried to apply these techniques to network management. So if you ever try to do this, you know how difficult it is to run experiments with that in testbed. So our idea was, why don't we create a platform that we can use to run a set of experiments where we have this logic and this machine learning logic that control the network. So the idea is that also we have some new applications that are very demanding in terms of requirements for latency throughput. So there is now a trend of using machine learning, AI, and in particular reinforcement learning to adapt the network behavior to the traffic condition in a reactive way, in a proactive way. And in particular, something that we are trying to do is adapting the network. So self-adapting the network, for example, with routing. So we adapt the routing to the different conditions, or scaling up, scaling down the resources as needed. So as I was saying, this is difficult to test, and in particular, can this solution scale to more large networks? So what we wanted to do is to create a distributed learning environment that controls the network. So since the network can be large with many devices and not the links, we can scale this logic across more controllers. So in a context of SDN, we have the controller, and so we want more SDN controllers that monitor the network and react. So we want to experiment with this, in particular deep reinforcement learning for our self-adapting networks. And now the question, a possible research question is, how can we distribute this logic? And so there are several options. And in this project in particular, we tried two approaches. One is individual and one is a collaborative. So we have different controllers. These controllers can just be selfish and they just manage the different sub-networks, or they can exchange some logic. So if we have the deep reinforcement learning model, they can exchange the weights, for example, of the neural network. And also, we developed an user interface that can facilitate the experiments, since we have realized how difficult it can be. Okay, and so this is the view of our solution. We have this network, and then we want all these components to run and to control everything. So we have this distributed reinforcement learning logic, but we have to program it logically centralized, because it's easier for a programmer and for a developer to run this experiment if everything is logically centralized. And then we want to create something that can be easier to manage and deploy with our platform. And so these are basically the components. So we have a front end, we have this web interface. So we developed this website that can manage the logic. And then we have the core of our solution, so the decision logic application. And this includes the reinforcement learning model, which, like I said, is distributed among possibly multiple controllers. So this is where the research happens, where you can apply your logic, your model, the one that you prefer. It's up to the programmer there. And then we created this testbed manager, since this application can run on many testbeds. So in particular, the difficulty is that if you change the platform where you want to run the experiment, you have to change your command. So what if we abstract this interface and we create this testbed manager that takes care of the different commands, and then you just program that and it adapts to the different commands. So for example, if you are familiar with Genie, you know that you have to run some commands, for example, with Genie only. But if you want to use CloudWeb, you have other commands and also Chameleon. There are mainly of that US-based platform, but hopefully something will be also in Europe. But so our testbed manager is the one that abstract this and allows to scale over different testbeds, so it's easier to run these experiments multiple times. And so this is just an example of the web interface that we provided. In particular, we tested this on Genie, GenieNet, which is a US-based testbed. And as any testbed, you can choose the topology that you want to run. So we also did this with this part. So you can choose the host, the switches, the links, and then the SDN controllers. But then, differently from all the others, we also allow to specify the logic. Okay, so like as I was saying, you can run the experiment wherever you want, and also you can specify simply the logic. So the model, the neural network, the number of neurons, the number of hidden layers, and also the number of controllers that you want to manage the network. So you just specify this logic, and then our product will take care of that and will deploy it for the user. So what we did is the development of the interface and also the development of some logic for self-adaptive networks. So we started with experiments of Mininet to validate the logic, and then we scaled that on Genie. In particular, something that we can see on Mininet is that this auto-scaling logic can reduce the energy consumption of the network and can increase the throughput of an application. We have these graphs where we change the network utilization. So this is a single controller network, because on Mininet we have seen how we have some limits because Mininet is an emulator that runs on the machine, so we have the machine's limitations, right? So when we scale this on Genie, we have seen that we can run a decentralized solutions that otherwise would be impossible, right? So we tested this on Genie and we realized how this decentralized approach can further increase the throughput and reduce the power. Okay, so, and as I was saying, this decentralized approach is only feasible in a very large testbed as Genie. So we focus mainly on Genie, but as I was saying, since we have developed this architecture with different components, we can hopefully scale even to different ones. So we have some outcomes for this project. We have published a paper at ISIN that will be presented in March, so very soon. And then we have, so this paper that was accepted was in particular about the models that we have developed. So this decentralized logic for reinforcement learning. And then we have other papers pending that we plan to submit soon about this experimental platform and about federated learning. Since now it's much easier to run this set of experiments, we plan to apply also federated learning logic that in NGI we didn't test, but we plan, we have starting the experimentation also to, since we have this distributed controller, they can exchange this information using federated learning. And then we try to study the sustainability of this approach and the privacy and efficiency of federated learning. This was just a 6-month project, so we achieved something, but there is something more that can be done. For example, I was talking about the distributed models, so we are trying now to apply federated learning, but there are other multi-agent reinforcement learning approach that can be used. Then we can also change the decisions that can be taken. So far we focus on self-adapting network, but what if we, for example, try to apply this logic for congestion control or routing or whatever we want to do? And then also we want to scale to different testbeds. There is Fabric, that is an initiative from US, where it's basically the extension of Gini. But also, since now we have the Recovery Fund in Italy, we have PNRR, that is something that gives university a lot of money. We are also planning to create a testbed inside the Italian university. So maybe we can use this EU project to run experiments also in something that is hosted in Italy or Europe in general. So this is the GitHub link to the project, and these are the contacts. You can ask anything, but also you can ask now to me if you have questions. So thank you.
Thank you, Alessio. And very, very nice work. As you mentioned, you worked mainly with the interface to Gini in the project, and there were different entry points or models required for Chameleon, Cloud Lab, and Fabric, and so on. Do you plan to look to see maybe extending this web interface to these other networks or platforms? Because that, to me, that could be a very valuable knowledge that you have gained in the different, the different aspects of the different platforms, to somehow bring that all into one interface. Have you thought about this, taking it forward?
Yeah, definitely. This is something that we want to do. The architecture that we developed allows us to scale over different. And so this is our plan. Also, there is something that I didn't mention, but there are new testbeds like Fabric and Chameleon that has GPUs, so we can use GPUs for training the model. And so this is something that we haven't tested yet in NGI, but we plan to do this in the near future. Mm-hmm. And also to verify if we can use this new hardware to deploy different models and new architectures also.
Yes. Well, I presume because Fabric is sort of, the next generation of Gini, perhaps that might be a good starting point in the scalability work.
Yeah, definitely. Thank you for your suggestion.
Okay. Jorge, do you want to ask?
I wanted to ask a question. Thank you very much for the presentation. You mentioned that because of the decentralized approach, you needed a large-scale testbed, and that Gini was very good for this. Because I'm not familiar with all the testbeds, the size of the US testbeds or the scale is larger than the ones that you can find here? Or is it because some people yesterday mentioned that there was an issue in Europe that there is not so much availability of resources to test? Okay, so they mentioned this issue that there were more availability in the US testbeds, but it's also a kind of a scale, a scope, the testbeds that they have there?
Yeah, so we started with Gini mainly because we were more familiar with that, and also with the other US-based platform. We know that there are some initiatives also in Europe, but given the fact that, for example, Gini runs in many universities in the US, it can run larger topology. I haven't shown in this presentation other results about the maximum topology that we can create with this, but we started with Mininet, that is a local emulator, and so you have like you can run like the order of 20 nodes here. And then if you use Genie, you can extend this to like 60 and even more. So that's why we choose this approach. Yeah, we also plan to try new ones. So let's see if something new came up with something interesting.
Thank you. Good luck then in the future.
And one last question. Oh, is there someone in the back? You go ahead first. Okay.
More data driven.
On just a second. It was much better.
For this nice presentation. I didn't get why you are using this reinforcement learning. Where is your markup process driven basis, which is very, very important?
Okay, so I haven't shown in the presentation, that's true, but we have this model that choose when scale the resources up and when to scale the resources down. So it changes, for example, it can dynamically create new switches or new links to face the congestion in the network. So in that case, the model was reinforcement learning. So I haven't detailed the state, the action, and all the other parameters that are in the paper. So the idea is that we collect some metrics, and that's why we need the controllers, because the SDN controllers that can monitor.
Then the federated learning is coming as meta learning step, to improve the behavior of the different local.
Yes, exactly. That's our idea. So logically, we can have one or we can have more controllers. And when we have more controllers, we need to distribute this logic. So one way is federated learning, but we also studied other ways of exchanging the logic.
Later, this is what we discussed.
Yeah.